what the function actually does is on the other side of the equation. So if we look at this definition of a function, the function f from a set A to a set B is just a rule. It's a way you correspond x values and y values. But f is the way that it's done. So you're going to stick a value in, that's an x value that goes in, and something's going to come out. That's your y value. But the rule itself for how that works is now going to have a little different name. It's either f or g or h, some other kind of a letter. And it's going to take one value from set A. So set A would be my x values. It's going to take one value from that set, and it's going to output another value. And that output is going to be called a y value. So the set A, all the values you can put in, you know from Math 21, that's called the domain. All the values that can come out, that's called the range. But what's important about a function is, when I give you an x value, you have to tell me exactly what the y value is, without any question. If I say x is 10, you have to be able to say y is 20. If I say x is 5, you have to be able to say y is negative 6. You can't have a question about it. That's what makes it a function. So if I said that x equals y squared, that's not a function. Because if I tell you x is 100, what's y? Maybe 10, maybe, what other number can I square? Negative 10, right, you don't know, what's y? Well, y is 10 or y is negative 10, that's not a function. For a function, when I give you an x value, you have to know what the y value is, there can't be any question. So we're gonna start doing things like this that we didn't do in Math 21. Squaring the y makes it not a function. That's what this exactly one means when I say exactly one element. So we're going to have to decide when we look at something, is it a function or is it not? Well, it all depends on, if I tell you a domain value, do you know what the range value is? So if we look at example number 1 here, this is set notation. If you haven't seen it before, it tells you that the values that are in set A, sorry, I'm trying to zoom in here. The values that are in set A are A, B, or C. Those are the only values that you can have for A. Do it this way. And the values in set B are 1 through 5. So if I'm trying to go from set A, which is my x values, to set B, which is my y values, if I know how that works, like if you tell me what A is, I know what the set B value is, then it's a function. But if knowing my value from set A doesn't tell me what B is, it's not a function. So look at those 4 in terms of the sets or the pictures, graphing from one to the other. Are there any there that you can say for sure are not functions? That if I gave you the domain value, you wouldn't really know what the range value is? Anything jump out?
C.
C, this one?
Yeah.
Okay. So if I told you the domain value was little a, would you know what the range value is that matches that?
I'm not gonna lie, I have no idea what you're even saying to me.
Okay. So these are the choices for the domain, right? Little a, little b, little c. Okay? So if I said, I'm closing my eyes and I'm picking a domain value and it's little a, do you know what range value matches with that?
1.
Yeah. Okay. So I do the same thing, I close my eyes and pick b. 1. I close my eyes and pick c. 1. Yeah, I know. If you tell me what the range value is, or the domain value is, the range is always 1. So this is a function.
So D isn't.
That's where we have a problem, right? With D, if I close my eyes and I say, oh, I'm gonna let domain be little a, what's the range? I don't know. It could be 1, it could be 2. Not a function. Because knowing what the domain is doesn't tell me what the range is. It splits 2 different directions. Okay, so that's why this is a function and this is not a function.
So A and B are functions.
You think? A and B. Let's say, so I say little a, it says 2. I know what that is. Little b, 3. Little c, 4. Yeah, that's a function. The problem with B is, what if I say little c? Do you know what the range value is? No. So this is a function and this is not a function. You've got to know for every single domain value, what is the matching range value? And I don't know. They didn't give me one for C. So the reason this is it's missing a range value for C. That's the problem here. For this one, it has too many range values. For A and B. It's okay for C. I know what's going on with C. So you don't want to have a missing value and you don't want to have too many values. Otherwise, it's not a function. Okay, so the way I always think about it is, do I have a value for every one of my domain values, and do I know exactly what it is? Do I have one value for every one of my domain values? And again, this is domain. What goes in is domain, what comes out is range. So most of the time, you're not going to have a picture like this. It's not going to map a set to a set or a picture. It's going to look like an equation, like we've seen before. Y equals x squared. It's an equation. That's the way we see it most times. And so you have to think a little more carefully. Okay, if somebody told me x was 20, would I know what y is? Yeah, it'd be 400. So this kind of a rule is pretty straightforward, and it is a function. Because every time I get an x value, I get one y value out. What makes it not a function is when I can't figure out what the y value is, like I said on this example. So, shortcutting it, if I have an even power on my y, it can't be a function. An even power on my y is going to cause me to not know, is it 10 or is it negative 10? Because when you square a positive or a negative number, you get the same thing out. So which is a function of x? This one is. This one's not. It all has to do with which variable is squared, or to the 4th, or to the 6th, or to the 8th power. That's one way that you can tell really quickly. If you scan through and something is being done to y that makes it an even power. Make sense? Mm-hmm.
If it's like cubed, would it be?
Okay, so let's think if it's cubed, and I said x is 1,000. Do we know what y is?
10.
Yeah, we know because it can't be negative 10. Yeah, so cube still makes a function because positive numbers give me positive back, negative numbers give me negative back. So there isn't any distinction when it's an odd. I know what it is. It's just the even powers. Yeah. Okay.
Will there ever be like not an x squared there? Like say I was like x squared or y squared.
Oh yeah, okay, there might be, and if there weren't an exponent, like if it said x plus y equals 1, that's a function because odd exponents, 1. you know, it's just assumed. So it's only even exponents on y that cause a problem. All right. Okay, so what I have up here at the top now is what we were talking about before, that, you know, I might not want to call it y, I may need another name. And most often the other name I use is f. That's just a common name for a function. So we're going to move away from the y equals x squared to something that looks more like f of x equals x squared. Where again, f is the name of the function so that I can have multiples. F of x is the value you get when you plug a certain x value in. F of x is a value that comes out. And x is what we call the independent variable. So it sort of looks like this. I always thought about it like this when I was learning math. I had this like black box. I don't know what's going on inside the black box. It's a mystery. But it's got a name. What goes on in there is called f. So somebody might take the number 3 and stick it into the box, and the number 27 might come out. So I think maybe I know what's going on in the box, but I'm not positive until somebody says, yeah, and when 5 goes in, 125 comes out. Now I think I really know what's going on in the box, right? What's going on in the box?
It's being
Cubed, right? Sounds like this f thing is a cube. So I would say I think that whatever I put into the box, so that's where the x comes in, whatever I put in looks like it's being cubed and then it comes out. So the f itself is that whatever is happening. The x is what you're putting in, and then f of x is what's coming out. And that's how the notation works. So, I mean, I could have been wrong. If they said, wait a minute, no, it's not 5, it's, I mean, it's not 125, it's, let me see, gotta use my math brain, which I'm not really good at. Okay, so it's, okay, so it's 47. Yeah, I'll do it that way. So it's 47 that comes out. Ooh, then I wasn't cubing. What was I doing?
multiplying by 10 and subtracting 3.
You got it. It was taking 10 times x minus 3. So, you know, I need a little more information to be able to figure out what that mystery box is doing sometimes. But once I see a couple of ideas, then I can sort of figure out what is going on inside the box. And that's often what the question is. Okay, but now, how I grade it is exactly what Gina said. I'm gonna, whatever you give me, I'm gonna multiply by 10 and subtract 3. That's the rule, that's f. Okay? So this is the independent variable that goes in. What comes out is the dependent variable, because it depends on the function. What comes out depends on what's going on in the box. What goes in is going to go in no matter what. And I always had trouble keeping those two straight too, so that's how I think about it. All right, so evaluating a function, that just means put the number in the box and what comes out. So if I want to evaluate this function for the number 4, that means all I want to do is everywhere I see an x, which is my independent variable, I'm going to put a 4 in. So I'm going to take the square root of 4 plus 4 squared minus 3 times 4 plus 9. And then I have to use my order of operations, which I know you worked on a lot in Math 21. Make sure that you do any exponents first. What exponents are there? I see 2.
It would be 2 plus 16.
Okay, and why are you saying 2?
The square root of 4.
Okay, and that's where I saw the first exponent. Don't forget, from Math 21, the square root of 4 means 4 to the 1/2 power. That is an exponent. So you got to do that exponent. Do that exponent, 4 times 4. And you could multiply, but I'm trying to be really orderly about it. I did all my exponents. But I can't do my addition or subtraction until I do my multiplication. 2 plus 16 minus 12 plus 9. Now that I get down to addition and subtraction, what do I do? Do I do the addition first and then the subtraction?
Yeah.
Yeah. Now see, I said that because my daughter was taught that in elementary school. She came home and did her homework, I checked it all, I said it's all wrong.